folks, picking up with this chapter 18 on electrochemistry. This stuff is so cool. We're going to be really getting into some big picture things like how your batteries work. But before we get into that, I want to review a little bit of our oxidation reduction chemistry, our RedOx chemistry. Okay, so we recall, for one, oil rig. Oxidation is a loss of electron. Reduction is a gain of electron. Some of you like the Leo says GER acronym, and if you do, that's okay. I prefer the oil rig, all right? So we're looking for a loss of electrons for oxidation and a gain of electrons for reduction. But in order to assess that, we also have to remember how to calculate the oxidation states, right? So let's just review those rules really quick. So any atom in its elemental form will have an oxidation state of 0. So for example, sodium metal or even oxygen gas will have an oxidation state of 0. So a monatomic ion, the oxidation state is just the charge of the ion. So sodium +1 has an oxidation state of +1. Chloride has an oxidation state of -1. So fluorine is always -1 in compounds. Of course, F2 will be 0. And it's tempting to also say, well, then shouldn't chlorine and bromine always be -1? And if you recall, way back when we talked about weak acids, we saw the chlorine oxo acids have different oxidation states. So we really just predominantly say fluorine is -1 and the others can be variable. So oxygen in compounds are always -2, except in peroxides, it's -1. The only peroxide that we will see in this class is hydrogen peroxide. So it looks like CO2 might be a peroxide, but it's not, okay? Oxygen is -2 in carbon dioxide. And hydrogen in covalent compounds is always +1. So when we apply these rules to this reaction right here, we can see sodium metal is 0, chlorine gas is 0, and when it makes this compound, sodium chloride, sodium goes from 0 to +1, and we have to think about how you go from 0 to +1, and that's from losing an electron. So if sodium loses an electron, it has one more proton than electrons, which will leave it positively charged, okay? And then similarly, chlorine, to go from 0 to -1 means it's going to have to gain an electron, okay? So we say sodium is oxidized, chlorine is reduced, and if you recall then, that means that sodium is the reducing agent, and chlorine is the oxidizing agent, right? So they're the opposite because really you have to think of it as, well, if sodium is oxidized, who did the oxidizing? Well, chlorine did, okay? And if chlorine is reduced, who did the reducing? Sodium did. So now here's an example, a combustion of methane. So we want to identify the reducing agent and the oxidizing agent. And I'll tell you right now, when oxygen gas is involved in a reaction, 99.999% of the time, it is the oxidizing agent, okay? But we should still go through just to check, okay? So we can see, for example, hydrogen in covalent compounds are +1. So it's +1 in methane. It's also +1 in water, so hydrogen doesn't change, okay? So, but that means now carbon over here has got to be -4 because there's 4 hydrogens each being +1. So this oxygen, I'm going to erase that arrow right there. So this oxygen right here is 0 because it's in its elemental form. But this oxygen right here is -2, and the oxygen in the water is also -2. So we can see that oxygen is going from 0 to -2, okay? And carbon, we forgot to calculate the carbon and carbon dioxide. that's going to be a +4. Okay, so oxygen to go from 0 to -2, that means it's gaining electrons. Okay, and methane to go from -4, let's see if I have enough room here to draw my arrow, to go from -4 to +4, that means it's having to lose electrons. So we could say if oxygen is gaining electrons, that means oxygen's being reduced, which means oxygen is the oxidizing agent, as we just said. That's to be expected 99% of the time. And methane, even though it's the carbon in the methane that's undergoing this redox reaction, the entire molecule has to be the agent, right? So if carbon and methane is losing electrons, that means it's being oxidized, which means, of course, it's the reducing agent. Okay, so hopefully that was some good review. There'll be plenty of review in the question banks for this type of stuff as well.